Hello, my name is Trista Crudup, and this presentation explores cybersecurity as a critical driver of supply chain resilience. From my background in engineering, manufacturing systems, and workforce development through I2E and Urban Terminal, I approach cybersecurity not just as a technical issue, but as an operational and system-level risk. Today, I will discuss the implications of cyber attacks on a broader landscape, and then I will demonstrate how a single cyber attack can disrupt an entire supply chain ecosystem, using the Colonial Pipeline incident as a primary case example. Modern supply chains are no longer linear. They are digitally interconnected systems that rely heavily on real-time data, automation, and networked infrastructure. Because of this, cybersecurity threats now extend beyond information technology and directly impact physical operations such as fuel distribution, manufacturing output, and logistics movement. A key issue is that risk no longer remains isolated within a single organization. Instead, it spreads across suppliers, distributors, and customers, creating system-wide vulnerabilities. This aligns directly with supply chain management principles, where interdependence increases both efficiency and risk exposure. Cybercrime is rapidly increasing in both frequency and economic impact. According to Viking Cloud, cybercrime is projected to cost businesses up to $10.5 trillion annually by 2025, with continued growth expected. This level of financial exposure indicates that cybersecurity is now one of the most significant risks facing global supply chains. Industries with high infrastructure dependency, such as energy and manufacturing, are particularly vulnerable due to their reliance on operational continuity. The Colonial Pipeline is one of the most critical energy infrastructures in the United States, supplying approximately 45% of fuel to the East Coast. In May 2021, the company experienced a ransomware attack that forced it to shut down operations for 6 days. This was a full operational shutdown that disrupted fuel availability, transportation systems, and regional economies. This case highlights how cybersecurity incidents can escalate into national-level supply chain disruptions. The Colonial Pipeline attack demonstrates a cascading failure across the supply chain ecosystem. The sequence began with a cyber breach, which led to an IT shutdown. This triggered an operational shutdown, followed by distribution disruption. As a result, fuel shortages occurred across multiple states, airlines adjusted operations, logistics networks were impacted, and consumer panic buying led to price spikes. This illustrates how a disruption at one node can propagate across the entire network, amplifying both economic and operational consequences. Colonial responded effectively in several areas. The company shut down operations quickly to contain the threat, engaged federal agencies, and implemented a phased restart strategy. However, the incident also exposed critical weaknesses. These included the absence of multi-factor authentication, reliance on a compromised legacy VPN, and the lack of a chief information security officer prior to the attack. This highlights a key lesson. Investment in cybersecurity tools is not sufficient without governance, leadership alignment, and disciplined execution. Cybersecurity incidents quickly evolve into enterprise-wide crises, requiring executive-level leadership. The CEO must coordinate decision-making, while the board ensures governance structures are in place before incidents occur. However, one of the most overlooked aspects is the workforce. From my experience in manufacturing and workforce development, cybersecurity is not just an IT function. It is a capability that must exist across operators, technicians, and leadership. Systems are only as secure as the people who manage them. Through the urban terminal model, we emphasize a pipeline of recruit, train, credential, apply, and advance. Embedding cybersecurity awareness into this pipeline is essential for building resilient industrial systems. To build cyber-resilient supply chains, organizations must take a system-wide approach. First, cybersecurity must be embedded directly into supply chain design, not treated as a secondary function. Second, organizations should implement zero-trust architecture and multi-factor authentication across all systems. Third, executive-level incident response frameworks must be established before a crisis occurs. Fourth, workforce development programs must include cybersecurity training at all levels. Finally, collaboration across supply chain partners is essential. Organizations must share threat intelligence, align security standards, and work collectively to strengthen the overall ecosystem. In conclusion, cybersecurity is no longer just a technical issue. It is a core component of supply chain resilience, operational continuity, and economic stability. The Colonial Pipeline case demonstrates that a single cyber attack can disrupt an entire network. Moving forward, organizations that integrate technology, leadership, and workforce capability will be best positioned to manage this evolving risk. Thank you for taking the time to engage with this presentation. As we have explored, cybersecurity is no longer a standalone IT concern. It is a critical component of supply chain resilience, operational continuity, and national infrastructure stability. The insights shared today are grounded in the Colonial Pipeline case study, supported by current cybersecurity risk data, and reinforced by established supply chain management principles. Together, these sources highlight the urgency for organizations to rethink how they design, secure, and operate their supply chains. From both an engineering and workforce development perspective, the path forward requires integrating technology, leadership, and human capability into a unified system of resilience. I appreciate your time and attention, and I welcome any questions or further discussion.